Hello everybody. My name is Cosport77, previously Technomode77, and previously before that, Wildcoder 2007. I know these names are corny, but yeah, that's what I have for an internet persona. So, this video is not about coding. It's not about HTML beginners tutorial part 2. As already clicked on the title, you saw it. It's chemistry video. Right now on my screen, it's monobasic acids, dibasic acids, and tribasic acids, so you know exactly what you're here for. It's about acids, right? So in this video, I'm going to be telling you guys about monobasic acids, dibasic acids, and tribasic acids. So what is an acid? An acid is something which, when dissolved in water, liberates H3O plus ions. All of these liberates H3O plus ions when dissolved in water. And H2O plus is hydronium. I'm pretty sure you guys know that. H2O and plus the charge being 1, right? Positive 1. So it's a cation, H2O plus. And it is it forms H plus when it's dissolved in an aqua solution, right? In which it is soluble. So now you must be thinking, if you're smart, you have already figured it out. So what's a monobasic acid, a dibasic acid, and a tribasic acid? So it's pretty simple. Mono means one, di means two, tri means three. So a monobasic acid, when dissolved in water, is gonna ionize to form one hydronium ion, dibasic two, tribasic three hydronium ions. It's really that simple, right? Now, let's say a monobasic acid. Now, let's say we have HCl. You might gonna be like, bro, how do you know that HCl is a monobasic acid? I'd be like, yeah, wait, I don't know HCl is a monobasic acid, but I know for certain that HCl is highly soluble in water. Why is it highly soluble in water? It comes from one core thing, and that is, if you read class 10 chemical bonding really well, which is the basis, which builds the base for this chapter, right? Don't come into this chapter without reading chemical bonding and periodic table. Periodic table is not that necessary, but chemical bonding most certainly is. So back to the chase. This, right? This here, right here, is a polar covalent compound, H2O, right? The charge distribution is not uniform. HCl is also a polar covalent compound, and you guys must have learned this from the organic chemistry chapter, sorry, from the chemical bonding chapter, that like dissolves like. So an organic oh my god, please. Polar covalent compound is going to dissolve another polar covalent compound. I apologize for that, guys. Yeah. So HCl and H2O. Now, this is going to be highly soluble. It's going to ionize. It will undergo ionization. H3O, HCl will go undergo ionization and will form H3O plus and plus Cl minus. These two ions will form. Now, you must be like, brother, how? So I know that this is a monobasic acid. That's because one hydronium ion is formed and it's almost completely, ionized in water, and it will not go undergo any more further ionization. So how is this happening? I know this. This is in my book. I wouldn't have clicked on this video had I known that, you know, this is the only thing we'll teach. Except this is not the only thing that I'll be teaching you guys. See, H, right? This is our dot. Let's say, please, guys, don't, make fun of this. My first time drawing on a note thingy, a note drawer thingy, whatever. So, you know that HCl's bonding, hydrogen, does not give an ion to chlorine. That wouldn't be possible, right? They share, right? So it goes something like this. This is a Lewis dot structure. I'm using the orbital method. They share, don't they? That's beautiful. They do share. You guys agree to that. Now, what the H2O does is that it kind of plays like a tug of war game with chlorine, right? To seize hydrogen. H2O wants desperately to form H3O plus because of the same thing which I said. And polar covalent compound will always try to dissolve another polar covalent compound unless it's an exception. So, in this tug of war, both sides make a few sacrifices. Chlorine here says to water that, hey, bro, look, I know this, like you're trying to take hydrogen from me. You can't take hydrogen from me, all right? I'll allow you to take hydrogen from me, given that you let me maintain my stability. Means what chlorine is claiming is that chlorine wants to keep this electron over here to itself. and it wants to let hydrogen go without any electrons. Meaning, and water is like, okay, I can't fight with this dude. This dude is, not, it's very strong. So see, don't mistake hydrogen and bond of H and Cl to be weak. It's not weak, it's extremely, extremely strong. It's very strong, right? So H2 is like, oh man, I can't win this war without a negotiation. So what they negotiate on is that chlorine gets to maintain its stability, but it gives up hydrogen, right? And it will form H3O plus. And this hydrogen is just going to be an H plus. And that H plus is going to combine with this H2O, right? This H plus is going to combine with this H2O to form H3O plus. Isn't that great, guys? Isn't that great? This is going to be H plus. This right here is going to become something like this. Cl cross 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 cross. Wait for it. Cross cross cross. And hydrogen's souvenir, hydrogen's leftovers, hydrogen's only electron, and it will become HCl minus, only Cl minus. It will become Cl minus because it has one more electron. So it will form H3O plus because hydrogen is positively charged and it's combining with H2O, and this will be Cl minus. And that's done. It formed H3O plus plus Cl minus. Isn't that remarkable? And now this whole reaction is reversible, by the way, so it's gonna be the reversible arrows. I apologize, guys. Please pardon me for that one. It's gonna be the reversible arrows, guys. Yeah, agree? I'm pretty sure you guys agree. Yep, you all good, guys. All right, so that's monobasic acids done. If you guys have any doubts, if you guys feel that you didn't understand one part, right? Let me just quickly show now. Hydrogen becomes after the war, right? Hydrogen becomes this. Hydrogen has no electrons, right? And this becomes chlorine. Right? This combines with the H2O like this. Plus. If you guys have any doubts about this, let me know in the comments. I'll try my best to help you guys, right? Now, let's talk dibasic acids, right? Let me quickly put the text tool here. Yeah, two. Now, dibasic acid. Now, this, if you notice one thing, this dissociation happened in one step. It was a one-step chemical balance. It was a one-step chemical, not a balance, it was a one-step chemical reaction. One design. Now let's recall dibasic acid. You must be like, oh, you don't know what's a dibasic acid. Let's say H2SO4, right? Combine it with, again, same thing, NaCl. Guys, please put it at 2x if you find this writing slow. Right? NaCl at a temperature less than 200 degrees Celsius. Agreed? When the temperature is less than 200 degrees Celsius, what you're going to have is NaHSO4 plus H2O. NaHSO4 plus HCl. H2O, HCl. Now, you must be like, hey, bro. So, I know this is dibasic because I'm getting two hydrogen atoms, right? 2H plus. Now, how is this H plus? That's because this is sharing. It's not H plus necessarily, but it's just two hydrogen. So it's, dibasic in nature. So now let's say we combine this with water, right? H2SO4 plus H2O. Yep. What you're gonna get right now, guys, is, so guys, it's gonna give you H3O plus. You mind that? H3O plus HSO4 minus. You'll find this in your textbook, right? HSO4 minus. Up further, you'll get HSO4 minus plus H2O. Now recombine with H2O to give H2O plus and SO42 minus. Isn't that right, guys? That's in your book. And now you guys will be like, bro. So overall, I know that H2, sorry, H2SO4 plus. Okay, guys, all of these are reversible, by the way. Can't believe I keep on making this mistake. I'm really sorry, guys. H2SO4 plus H2O is gonna give you overall how many hydrogen ions? One, two. Two H3O plus and one sulfate ion, right? It's that simple in the book, right? Now let's look at it from another angle, from a beautiful angle, from the beautiful angle of real chemistry. You know, let's say you have sulfur, right? How do you plot sulfuric acid? Sulfuric acid's diagram looks something like this: a large central S, sulfur, to indicate sulfur, and on the sides, let's say you have a double bond O, and you have a vertically symmetrical OH and a vertical symmetrical OH, right? And this is going to be a single bond in between both. Very strong bond, mind you. All of these bonds are extremely, extremely strong, right? Plus H2O. Now, this is the first step. No ions here, just one H, two H, H2, one S, four O's, H2S4. And reversibly, when both of these react, what happens is that one of the hydrogen ions, you know, one of the hydrogen oxygen ions, like let's say this group, let's consider this group, when it reacts with oxygen, water, what happens is that again, one of the hydrogen ions is liberated by another game of tug of war. H2 again fights with O about, hey bro, give me the hydrogen, ion. And oxygen first is like, no, bro, I'm a very strong bond, you don't want to mess with it. But eventually, oxygen starts to lose, and they eventually, come to a deal and another agreement, a very similar agreement, which we saw in the case of a monobasic acid, right? The agreement being that, bro, look, look. I am oxygen. I have six valence electrons, right? I was bonded with hydrogen with one valence electron, right? I was doing this with hydrogen, right? And so basically I am not stable. This OH group is not stable, but I am very close to stability. I was previously, I needed two electrons to become stable, but now I just need one electron to become stable. So yeah, so basically to maintain the stability, please let me keep this hydrogen, this electron from hydrogen. And H2O, who is also, losing some power, goes like, yeah, sure, bro. You get to take the electron, but give hydrogen to me, right? So basically what happens here is this. At the very core is cross, circle, circle. Hydrogen has nothing. It's just a lone hydrogen atom which combines with H3O, H2O, sorry, to form, which combines with H2O to form H3O plus. It's an H plus ion, right? It combines with H2O to form H3O plus. And overall, so from this step alone, you get reversibly, you get, right? Reversibly, you get H3O plus. Plus, what do you get? What else is left over, guys? Guys, so one hydrogen gets sent away. One hydrogen is like, no, bro, you go away, bro. I need to keep the rest of my kingdom preserved, right? Oxygen. This oxygen is gonna get a negative charge because it gains one electron, which it was previously sharing with hydrogen. It's gonna get to keep that all by itself, so it's gonna be oxygen negative, right? Right, O minus on top, and it's still gonna mention symmetry. It will be OH. Now this right here, if you count, you will see that there is one hydrogen, four oxygens, and one sulfur. So this is HSO4. Now you'll be like, bro, what is the charge, right? Where's the charge in this? I'll say to you, bro, if you look at it, there is only one negative charge up here, and that's one electron, one delta, right? It gained one electron, so the overall charge of this whole thing becomes -1. It's really that simple. So in total, you get H3O plus and HSO4 1 minus. So that's one step taken care of. Now, if you look at this, you'll be like, hey, wait, O and H, there is another ionizable hydrogen to it. So if I were to put this thing in water again, this HSO4 compound, this bond is likely to break, and this hydrogen is supposed to go to H2O again. And guess what? You're not wrong at all. This step would continue, it would follow, it would continue. Right? Are you guys getting the hang of this? I think you guys should be getting the hang of this. O minus, O double bond S, double bond O, O and H. Same way, bonding. And now again, H2O. Now you add H2O to again. And um, this time the compounds they know the drill. But still, this bond is very strong. H2O again does the same thing as it did previously with this first step of the dibasic acid, combination with water and monobasic acids. So again, this hydrogen is gonna go, but one electron is gonna be gained by this. So basically, what you'll have is that this. So you'll have H3O plus for sure. Very good, very nice. H3O plus, yeah. I have the H3O plus ion now. I am the powerful one. O minus. All right, it's a little clustered here. O minus S double bondo, double bondo, and symmetrically it's gonna maintain symmetry. Oh, minus, right? Same thing as in step one. It's the same thing is gonna happen again. O minus. It will just form O minus again. And this time, if you look, you know, really hard, you'll see that SO4. Huh. The moment you say SO4, oh my god, that's SO4 2 minus. Well, how is it 2 minus? Can I see 2 minus? Yes, you can. -1, -1, that's -2. And that's beautiful, I think. This right here is sulfate. The common, ion you have been studying since class, 6, 7. Doesn't matter. No, I'm not talking about the joke 6, 7. I really mean it. Sulfate. It's such a common ion. Everybody knows about it. It has a charge SO4 2 minus, and you just kind of made SO4 2 minus right now. Are you guys copying these diagrams with me? I think you guys should. This is beautiful. I think that's awesome. You know, every single subject will seem monotonous and boring as long as you do not appreciate the beauty in it. Science is science because it is science. It's not to mug up this equation, that equation. It's to understand what's going to be TS behind the scenes, right? It's beautiful. That's taken care of. That's a dibasic acid. Taken care of fully. Done. Are you guys agreeing with me? Are you guys happy? Are you guys okay? I think you guys are. If you have any doubts, same deal. Go to the comments. Let me know. I'll try to answer the doubts. So now we'll drop the finalizing thing. So basically, H2SO4 plus H2O is finally getting me how many hydronium ions? One. That's one, and that's two. So two hydronium ions, reversibly two hydronium ions plus SO4 2 minus. We'll consider this at the end. Right? So you guys just write that. I'm pretty sure you guys got the hang of it. Let's talk number 3, tribasic acids now. Now, a tribasic acid, if you guys were focused till now, right? You guys will be able to very easily grasp this part. It's not going to be difficult for you guys anymore. It's going to be a walk in the park. Let's say H3PO4. H3PO4 is a tribasic acid. H3PO4, when you add it to water. Same drill, guys. I'm gonna write the equations first, and then we're gonna get to the main derivation thingy. And you're gonna get H3O plus, then you're gonna get HPO4, HPO4 minus. Now this HPO4 is gonna combine with H2O. Combination done. Okay, so H2PO4, not HPO4, H2PO4 is gonna combine with H2O, and it's gonna give you H3O plus again, plus HPO4 minus. This ionization happened in two steps. So this is a dibasic acid and it's giving you two hydrogen ions. This one, HPO4 minus, also has, unfortunately for you people, another ionizable ion, hydrogen atom. So it's gonna give you guys H3O plus PO4 3 minus. Alright, this is gonna be HPO4 2 minus. 2 minus. Make sure. Right? And so H2PO4 plus H2SO plus H2O is finally gonna get you 3 hydronium ions, hence the name Tribasic, 3H3O plus, with the charge obviously being 1 and 1 PO4 3 minus 1 phosphate ion. Is it really that simple? Is it really that beautiful? Yes. Now, the main thing, the structure. What is the structure of H3PO4? H3PO4 structure goes something like this. This is phosphorus. This is a double bond with O. Mm, Here is one OH group. Here is another OH group with another OH group. And here is the final hydrogen. Just hydrogen, right? So 1, 2, 3. 1, 2, 3. H3PO. Yeah, this is gonna be an OH group as well. So OH, OH, so 3A, 3O, 4O actually, 3 H's. Let's make it H3PO4 plus H2O. The doom and misery starts right now. So this is step 1. Now when this happens, what is gonna happen, guys? Same thing. One hydrogen, H2 is gonna play a tug of war with phosphorus. Oh, no, not with phosphorus, the oxygen. OH being a strong covalent bond is gonna do some damage to H2O. H2 is gonna do damage to some OH, and both of them are gonna come to an agreement where they decide that, oh, I get to keep the hydrogen thingy. Please let me keep it. So it's like, okay, sure, brother, but give me the hydrogen plus ion, cation. Give me the hydrogen cation. And I was like, okay, sure. I just need to be a little closer to stability than I was before. And I was like, okay, they're good friends now. And double bond O plus H3O plus. By now, you guys have probably figured out it's H2PO4 minus 1, 2, 1, 2, 3, P, O. So that's 4 O's, right? Yeah, so 4 O's. So H2PO4 minus with the charge being minus 1. Now, H2PO4 minus H2PO4 minus. Now, for the second part of the equation, we have H2PO4 H2PO4 minus, right? Let's just draw the structure, shall we? B, B, OH, O, double bond, O, plus H2O. Don't forget to give the negative chili chart signs. This. Again, same thing will follow. Hydrogen will go to H2O. This time you'll get OH, O minus, O minus H, sorry, P. Yep, this is gonna be P, double bonded with this O, and you're gonna have plus H3, And don't forget to put this little thing here. Yeah, H3O plus, right? And this right here is 1, 2, 3, 4 O's again. H, one H only, HPO 4, two negative charges, so HPO 4 2 minus. This right here is HPO 4 2 minus. And this being the final step, we'll have HPO 4 2 minus. Let's just draw the structure. Kind of got a habit of it, no? OH, P, O minus, O minus, double bond with O plus H2O, blah blah blah. You're gonna get OH, OH. So this again, tug of war. With this hydrogen is gonna go here, right? It's gonna break this very strong covalent bond, and this will form O minus. So you will get, guys, O minus, P, double bond O, O minus, O minus, and plus H3O plus. This right here, guys, is PO4, 1, 2, 3, 3 minus. And this is a phosphate ion. In total, we have 1, 2, 3 hydronium ions. And this dissociation is happening in 3 different distinct steps. So, hence the name tribasic acids. So, this portion is covered. And I don't know, guys, if you enjoyed this video. If you guys have any doubts, please let me know. And if you guys have any feedbacks, if you guys felt like I did something wrong, which is a possibility because I'm also a student, please let me know down in the comments below, and I'll make the necessary rectifications. I doubt there will be any mistakes though, but still, there can be mistakes. So I'd like to thank you all once again for tuning into this video. Please drop a like or hype this video up if the option there exists, because that's gonna help my channel grow. And I think that's lovely. Thank you all for watching this video. I guess I'll upload more videos every now and then, but it's not gonna be a very consistent upload, so I'm not a full-time YouTuber. um Thank you guys for watching this video. I'll see you all in the next one, I suppose. Yeah, all right, bye.